Okay, I want to continue lesson discuss on the effect of fabrication in the analysis of definite trust using stiffness method. Okay, let's look at the example 14.7 in the textbook. Okay, this is the truss in figure 14.15. Okay, determine the force number one and number one. What in member means member forces of a pin connector assembly of figure 14.15. If member two was made 0.010 short before it was fitted into place. Okay, take AE equal to 8,000 kilonewton. Okay, this truss is the same truss like what we have discussed in the previous session, but this time this truss will be analyzed by adding the effect. Okay, the effect that will be discussed here is effect of fabrication error. Fabrication error means that okay, during construction the member or any one of the member is fabricated maybe too short or too long. It is just like this. Let's say we want to let's say during construction the member or the element should be 8 meter, for example, but during construction due to the error or due to fabrication error, it is shorter 0.01 means it is 7.99, not 8 meter as it should be. So maybe it is too short or shorter than its original length or longer than its original length. Normally this error will give will give the effect to the displacement as well as forces. Okay, it is called as fabrication error. Okay, it can be negative, it can be positive, depending on the situation. If it is fabricated too shorter than its original length, we consider it as negative, and if it is fabricated longer than its original length, it is considered as positive. Okay, so this is the same truss. There are 4 nodes and 3 elements. Okay, so since this question use the same truss, so we just I just want to highlight or focus on the effect because we will use the same case since this is the same truss. Okay, so if we refer to the solution given in the textbook, again this is the same truss. So the solution also focus on the effect only, since the member is short. Okay, this is member 2 was made too short. This is member 2 was made 0.01 meter too short. Okay, so shorter means negative. So the fabrication error value is actually delta L. Okay, shorter means negative 0.01 meter. So means that during construction this member is fabricated shorter 0.01. Okay, 0.01. So this will give the effect to the displacement and the reaction as well as member forces. Okay. So since this is member, so member has 2 node. Here is the node, this is the node. Okay, So we have to distribute. This will give the effect to the nodes, and we have to distribute this into 4 values based on the degree of freedom. This effect is called as equivalent nodal forces, the one that I have mentioned previously. Equivalent nodal forces. It is called as equivalent nodal forces. Okay, remember that I've mentioned about this previously. Okay, whenever we want to solve for the displacement or reaction or the member forces, okay, first important step is having the force displacement equation. It is force displacement equation. And force displacement equation is also known as stiffness equation. Okay, the original formula for the force displacement equation or stiffness equation is Q equal to KD plus Q naught. Okay, where Q is nodal forces, D is nodal displacement, K is stiffness metric, structure stiffness matrix, Q naught is called as equivalent nodal forces. Okay, equivalent nodal forces, this is the one that I want to discuss right now. The equivalent nodal forces. What is actually equivalent nodal forces? What's the difference between nodal forces Q and equivalent nodal forces? Okay, equivalent nodal forces is actually can be distributed into three conditions that we need to consider as Q naught. Three condition. Condition number one is fabrication error. Condition number 2 is due to temperature changes, and condition number 3 is due to loading, external loading. Okay, basically these two is normally occur in truss. And for external loading, this one is for beam as well as frame. Okay, so equivalent nodal forces, what is the definition, the simple definition of equivalent nodal forces? Okay, due to fabrication error occur for the member, same as temperature changes means if the structure or if the element have temperature changes, okay, normally the member will take that effect, not only the node, the member. Okay, same goes to fabrication error. That is why in the question mentioning about member 1 is fabricated, member if we refer to this it is also mentioning about member 2 was made 0.01 meter too short. So all these three effect, fabrication error, temperature changes as well as external load, this is all about member. this is not about nodes, this is about member. Okay, nodal forces, it is about nodal force. Nodal force means force that is subjected directly at nodes, that is called as nodal force. Nodal force. Nodal displacement means displacement that is occur at nodes. Displacement that is occur at nodes, that is nodal displacement. However, when we look at to the equivalent nodal forces, it is about member, it is not about node. Equivalent nodal forces is about member, means that for fabrication error and temperature changes, okay, if we need to consider the effect of these two in truss, okay, it is about member. Member 1 is fabricated 0.01 meter too short, or member 2 is fabricated uh, 2 millimeter longer than its original length. So it is about member. Okay, that is for truss. Normally a fabrication error and temperature changes, we will ask in truss question. And another one, number 3, EL is external load. External load for beam and frame. What does it mean? It means that it is about member. So means that the external load, the loading is subjected along the member, like UDL, uniformly distributed load, or triangular load, or there is a load, a point load that is subjected on the member, at anywhere on the member, not at the nodes. Okay, anywhere on the member, not at the nodes. Okay, so remember this, the equivalent nodal forces is all about member. Is all about member, not nodes, member. So if this is about member, and in stiffness matrix method, member cannot carry loads. So we need to distribute. So we need to distribute to the nodes. Okay, so how to distribute this? Because member cannot carry load, so we need to distribute to the nodes. Because stiffness matrix method is about the displacement. Okay, we find the displacement and we find the forces at nodes, not member. So whatever forces that is subjected towards the member, we have to distribute to the nodes. So equivalent nodal forces is about that. Okay, so for fabrication error, we have the formula. Actually, we have the formula to distribute to the nodes. Means that if it is for truss has member has 2 nodes, means 4 degree of freedom. Means that we have to distribute this into 4 values according to the degree of freedom. Same goes to temperature changes. Okay, and as well as the external loading, in beam, we have to distribute to 4 values. Okay, depending on the degree of freedom. And for frame, since frame has 3 degree of freedom per node, so we have to distribute the external load into 6 values. Okay, using the formula. Okay, for fabrication error and temperature changes, remember that this is force, and force unit, the unit is in kilonewton. And we have to distribute the value into 4 values. Okay, let's consider this example. This is about fabrication error, and the delta given, delta L, fabrication error is delta L, is negative because it is shorter than its original length, 0.01. Okay, so we need to, okay, member 2 means Q2 not Q Okay, we use small letter because this is for member. Remember, capital letter is for the reaction at the support. Okay, member forces we use small letter. This is equivalent nodal forces, also we use small letter, but we have put not for, there is special symbol for equivalent nodal force, Q naught. So Q naught, the capital Q is for the structure, for overall, and Q, small letter of Q, small letter of Q is for one by one member, So and this is about member number 2 or element number 2, so this is Q2 naught. Q1 naught and Q3 naught in this case is 0, because only member 2 get the effect of fabrication error. Okay, remember that we need to distribute this value into 4 value depending on the degree of freedom, xy, near xy, far xy, 4 value, and the unit must be remain in kilonewton. So this will okay, this one we will get the value from the CXCY that have been calculated. Okay, CXCY, this is how we distribute the value. So normally what I want to suggest is, I don't want you to remember the formula anyway. This time you don't have to worry about the formula, because all assessment is open book assessment anyway. For me, previously during for the student, for student taking examination, this formula will not be given. I always remind them to play around with the unit so that you will get the right formula. Okay, so it is delta L over L, delta AE, delta L over L. Okay, how to distribute into 4 values? We have to times with CX CY negative CX negative CY. So CX CY negative CX negative CY. Okay, so we will get 4 value. Okay, AE delta L over L. Why we need to divide by delta L? Because delta L, the unit is in meter. Here unit is in meter. And CXCY, there is no unit. No unit for CXCY. Here no unit. No unit for CXCY. So if I want to have the K, okay, AE is in kilonewton, and Q, okay, Q is in kilonewton. So we how to make kilonewton. Okay, if here delta L is in meter, so we have to divide by length, the length for that particular member. Okay, so refer back to the formula given here. It is AE delta L over L. Okay, so what most important is the label. The degree of freedom label is very important. Okay, because we have to label this just like what we label for the stiffness matrix for element number 2. Okay, based on the arrow from near to far. It is 1, 2, 5, 6. 1, 2, 5, 6. So the most important thing is here 1, 2, 5, 6. Okay, so we will get 4 value. Okay, I continue here. So we get 4 value. Okay, 4 value. So it is AE 8000, AE is 8000 times delta L is negative 0.01 divide by length length for member number 2 is 5 meter. 5 meter times with cx is negative 0.8. 0.8, so we get 12.8. Okay, we get 12.8. Here is 12.8. Okay, 8,000 times 0.01 divided by 5 times 0.6, it is 0.96. Sorry, 8,000 times 0.01 divided by 5 times 0.6, it is 9.6. So this is 9.6. This is negative 12.8. This is 9.6. Okay, so for the equivalent of the forces, so it is just like K, Q naught is equal to Q for member 1 naught plus Q for member 2 naught plus Q for member 3 naught, like this. So for overall Q, for the equivalent nodal forces, okay, Q naught for overall, right, it values 1, 2, 3, 4, 5, 6, 7 and 8. So Q1 naught and Q3 naught, since there is no effect, the value is 0, 0, 0, 0. Okay, so 1 for position number 1, this is 1, 2, 5, 6. 1 is 12.8. 1 is 12.8, 12.8. 2 is 9.6, 9.6. 3 is 0. 4 is 0. 5 is negative 12.8. 6 is 9.6, negative. This one negative. Negative 9.6, 7080. Okay. Okay. So what to do next? So what to do next? So if we want to determine the displacement considering this effect, okay, this is Q minus Q. The formula is Q is equal to KD plus Q naught. Okay, if I want to consider only unconstrained system, because we only consider unconstrained system in order to determine the unknown displacement, so I have to write it back. Okay, Q is 0, 0. Q here is 0, 0. Okay, AE 1, 2, 1, 1, 1, 1, 2, 2, 1, 2, 2. Okay, 0.378, 0.378, 0.405, 0.096, 0.096. Am I right? Am I right? Yes, correct. Okay, times with displacement D1 and D2, the unknown displacement, plus, okay, we take this value, and this value. Position number 1 and position number 2, 12.8 and 9.6. 12.8 and 9.6. Okay, so we rearrange back this, and we consider AE value 0.378 times 8,000, we get 3024. 3024. 8,000 times 0.096 is 768, and 8,000 times with 0.405 is 1000 times 8000 times 0.405 3240. Macam tak payah lah, tak pergi lah. Tak payah sekarang lah. Okay, it's 0 minus 12.8, negative 12.8. And negative 0 minus 9.6 is negative 9.6. So we solve for the displacement. Okay, we use simultaneous equation with two unknown. A1 is 3024, B1 is 768, C1 is negative 12.8, A2 is 768, B2 is 3240, C2 is negative 9.6. Okay, so we get D1 equal to negative 0.0037 meter, and D2 is equal to negative 0.00209. Is it the same? Okay. Okay, same answer. Okay, so this is the displacement considering fabrication error. Okay, so that's all for this session. For the next session, we will discuss the effect of temperature changes. Thank you.